Hello, everyone. Welcome to tonight's live stream. It's the last one because we've got the last assessment tomorrow. So that's nice. That's nice. Well, there's a few questions popping up at the moment that I'm just going to start with. First question, we'll go through that. If the paper has an essay question, would it be bullet point answers or full sentences? Individual bullet points are fine, but they have to be full sentence bullet points. But in no way am I expecting paragraphs of text. In fact, I would discourage you against doing that. That is the road to repetition and repeating yourself and just ongoing, not great answers, to be perfectly honest. Bullet point full sentences will stop you repeating yourself, will get your point across, and make your answer much more clear and concise. The second one, which is, will we have to write an algorithm for this paper? Yes, you will. We're going to have a look at some algorithms today, but essentially, you can write it in whatever you want. You could write it in Python if you wanted to. It wouldn't really matter. That's the beauty of having the Welsh exam system. We have that to go with. And the only question I haven't answered in the chat, what would a subroutine question look like? It'll ask you to write a subroutine for either a search or sort algorithm. And again, we'll have a look at those tonight. So don't worry, that will be covered in everything we're talking about today. Right, so let me get the banner off, the comedy gold banner, and then we'll get started. So we're going to start with subroutines tonight, and I'll be honest, I've spent quite a while making these slides today, so they are going to be absolutely beautiful. Let's have a look. So first of all, let's try and imagine what a subroutine is. And I've got here on the right-hand side, I've got a simple subroutine there, which we'll talk about in a minute. I say simple, I bet it reasonably complex. But a subroutine, as you'll remember, is just a subprogram. And it's just a way of writing some code that can be called by other lines of code. It's a bit like a recipe. It's instructions on how to do something because I'll need to do that a few times. So what we're looking at is ensuring that we can repeat that by just calling one line of code rather than copying and pasting it. And that just makes it much, much easier. So let's see what this subroutine does and how it works. So you'll probably guess that by its name, backwards, it converts text into backwards text. Now, you may know that you can do that with just some square brackets and a couple of numbers. Yes, you can. It's probably much more efficient than my subroutine, but there we go. It's the first one I thought of. So what this subroutine is going to do, is going to take in an argument, your text, so that we're going to give it some text. It's going to make a variable called backwards text. It's going to go through the entire range of numbers, and it's going to add the text in backwards one at a time by concatenating it into this, and then it's going to send it back. It sends it back to this program here, which is the main flow of the program, which is an infinite while loop, or a dirty while loop, as we like to say, which asks for some text to be entered and then prints out the backwards version of it. Let's see that executing, though, because that's where the actual fun comes in. So program starts executing on line 0, and it sees that first word def. Now, as far as the computer is concerned, definition, a subroutine, is essentially the same as you walking past an open cookery book in your kitchen. You don't immediately stop and cook pancakes. You just walk past it. And that's what the computer is going to do. It's going to go, okay, well, I'll remember where that is, and I'll go on to the next block of code that is in line with that. So it's, all the way over to the left, that doesn't have a def in front of it. And it's this dirty while loop. So we get into a dirty while loop, and we're going to repeat lines 7 and 8 forever because I didn't write a way out of it. And the first thing that's going to happen is we're going to create a variable called myText in memory space, and that's what I've done at the top there. There is our memory space. Can we even see that? Because I've got white text over the top of it. Good thinking, Mr. Morgan. And what I'm going to do is I'm going to shoot off down the bottom a minute of the screen because I've just realized that I've got stuff at the top. So we've got a variable there, myText, which is going to hold whatever the user typed in. So let's see, what did the user type in? Oh, the word memorize, a very useful word at the moment. Seems to be representing what a lot of the stuff I'm seeing is anyway. And so that's done, that's stored in RAM. And then we go on to this line. Now, this is where things start to get a bit more interesting. It's a print command, pretty standard. But in the print command's argument, in the brackets, it's saying to run the backwards subroutine with myText. So this is what's going to happen. It's going to run a pointer all the way up to the top, of course, keeping track of where it was, and it's going to create your text as a variable and copy what my text was into it. Then we're going to create backwards text, which is just a blank variable with string properties. And then we're going to create a loop. Now, loop creation like this, you've never seen this before, because we need two variables. We need a variable I to store the incremental value, or the incrementing value in this loop. But of course, that bit on the right-hand side, the range, well, I've never really showed you what that looks like before. What does range actually mean? Well, in this case, the range is going to be a list, which starts at the length of your text. So how many letters there are, -1. It goes until 0, and it goes -1 at a time. Now, what that actually looks like is the computer does this in memory. It goes and creates the range, it creates an array, and it populates it with the values that you've indicated. So I'm starting in this case with 7 and going down to 0. Now, the way the for loop works is that I becomes the first value, and we keep looping line 3 until we've gone down all the way. Moving down then, onto this, I is currently 7. Backwards text plus equals, that means concatenate, we're going to glue a letter onto it, is your text, square brackets I is 7, which means it's the last letter in the word memorize, which means at the top right, backwards text will become the letter E. Great, so back up to the top of the loop now, because we're going to increment I. That means I is going to become 6, because that's the next number in our range. And we go back into our line of code here, and we're going to say, right, well, add letter 6 in letter index position 6 to backwards text. That's the letter S. And so what we're going to do, the backwards text will become ES. So shockingly, we're going backwards. Let's see what happens next. We're going to increment I. That's going to go down. And so I is going to become the value 5. But, you know, as we're doing this, this is getting a bit boring for me now. I'm not sure about you. Repeating this same old, same old. But let's see what can happen if we keep going. Yep, we're getting the next letter. And if Dr. Strange gets that Eye of Agamotto now and fast forwards time a little bit for us, this would be really nice. And, oh, fantastic. We've got all the way to the end. That's saved us a few minutes, hasn't it? Fantastic. So you'll see there in the backwards text in the top right-hand side now, we've got the word memorize backwards. Now, when we get to the end of our array, we end up saying, well, the for loop's done now. We've used all the values in there. And we go to this bottom return statement here, which returns backwards text. Now, what does that return do? Well, return will send that value back to the line that called it, like this. What's going to happen is backwards text is sent back into the actual call. So the call is replaced by whatever's sent back. It is the text ESIROMEM, memorize backwards. And then the computer works out what it's going to do with that line. It's going to print that text. So that text is going to appear. Now, I just want to stop for a second there, because you'll see that we've currently lost everything except the variable myText. And that's because all the other variables were part of the subroutine. They were local variables, which means they've now all disappeared. Anyway, we print that out. Bada bing, bada boom, we are done. And we are going to go up and continue our infinite loop. But all of this is fine, and all of this will work lovely. But why do we do this thing here? Why are we using a variable name inside of the bracket? Well, that's a parameter, and that's a value that's going to be sent into the program. It's a bit like the ingredients in a recipe, but we send it in as if it was a variable. I'm going to get this up. Yes, sorry, I wrote it directly into the slide, so it probably is slightly wrong. So yeah, don't type it up directly. So the idea of a parameter is that it's a place for us to send data or ingredients into the subroutine. And there are a couple of different ways we can do it. One of the ways, sorry, I've got ahead of myself. The important thing is that code that calls the subroutine, this bit here is literally replaced with whatever is returned. And that's quite a nice, useful thing. So if Dr. Strange gets us back in time a little bit, so we can see that initial point where it's calling the subroutine, we go into it and we create that variable, your text, And one of the ways that parameter passing can work is this. It copies the value directly. Now, what this is called passing by value. And what passing by value means is that a local copy of the data is created for the procedure and discarded later. It's a local variable. So we just copy it, is passing by value. Question here. Could a question about parameters come up? More than likely, the question you'll get is on the topic of subroutines. And obviously, I'm talking about the entire thing. So parameter passing is a common thing that could be asked because it is one of the more higher level concepts. So passing by value is great, but there is another way. He says, confidently clicking completely the wrong buttons. And let's get Dr. Strange to use that Eye of Agamotto. Send us back, Dr. Strange, and let's look at a different method. There we go, back again. So this time when we call it, we're going to use a different method. We're still going to create the variable, but this time, instead of copying it, we're going to actually just point this variable at the previous one. And you might think, well, why are we doing that? Well, that saves space. Copying the variable uses loads and loads of RAM. So if we do that every single time we need to make a copy, we're going to fill our RAM with just duplicates of the same data. This way means that we just point back to the old one and save ourselves a load of space. And this is called passing by reference. And this is where the memory location of the data is passed to the procedure rather than the value of the data, which is great. But let's put these two types of parameter passing against each other. Let's put them in a good old-fashioned Mortal Kombat battle and see how they work. And for this, I've written a slightly different subroutine here called pluralize. And the point of pluralize is all it's going to do is it's going to add the letter S to any text that we type in. And then it's going to tell us that the singular becomes the plural version. So on the left, I've got passing, I've got the, on the left, I've got passing by duplication, and on the right, I've got passing by putting a pointer, putting a memory location into there. So the program runs, we type in the text. In both cases, it creates a variable, and the text is typed in. In this case, what do we get? We get cat, because I didn't want to be there writing that forever. Then we go to the next line, and you see the next line is a print statement, but it's got a subroutine call in it. So the program will work on the subroutine call first. So it jumps up here. Again, it points, it keeps an eye on where it was and jumps up here, and it creates your text. Now, here's where the difference occurs, because you remember the blue one will copy the value of cat, and the green one just points to the previous one. So every time you see the variable your text being used, in the blue version, we're using the copy of cat, and in the green version, we're just being pointed back to the original memory location. Okay, this next line, I'm going to append an S onto the variable your text. So if we do that, on the blue side, we'll see that we've got cats in your text. And on the green side, you'll see that your text is still a pointer back to the original, but this time, the original has become cats. So you can see there that there's a big difference between the two types of parameter passing. The one in blue, the original, my text, is still cat. And in the green, where we're passing by reference, the original has changed. Now that has some issues, because when I return this now, I'm going to return both values. You can see pluralize my text has given us cats in both cases. So that would be replaced in blue with the word cats and in green with the word cats. So the word cats is definitely going to be printed. The problem comes, now those local variables have vanished, what's left? What's left in memory? Well, on the blue side where we created the copy, the word cat is still there. On the green side where we pointed it to the original, we've changed the original and it's become cats. So there's an issue there. Because now, when my computer decides to pull in the value of my text, on the blue side, it's going to get the word cat. And on the green side, it's going to get the word cats. Now, what that means when we print them out is the blue one does it right. Cat becomes cats. The green one doesn't make any sense. Cats becomes cats. And it's not great, because passing by reference has unintended consequences. Because it changes the original value, we don't know what's going to happen with that original value in the rest of the program. So unless you are desperate to save space, you should really try to avoid this at all costs. Just wait until someone wants to pluralize Prius. Priuses? I think it would be apostrophe S. I quite like yes. I'm sure it'd be all right anyway. So that is subroutines. That's what you need to have a think about for that. The question will be a written question, so you will have to bullet point answer it, and will be something to do with subroutines. Passing by reference is pretty good because it uses much less memory, but it does have those unintended consequences. It does, because it points to the original, it can cause problems like that. Now, I'm just going to put this comment up before we move on. Pre-I like cacti. Potentially, I'm not a linguist. We'll have to go to the MFL department and ask them how do we pluralize this particular thing. Now, the second topic we need to talk about tonight, the second question will be about sorting and searching algorithms. Now, realistically speaking, your question is going to be about search algorithms because although sort and search algorithms, because sort and search algorithms are things you need to study, the sorting algorithms tend to be more complicated, and they tend to be asked in the Year 13 papers. The Year 12 papers tend to limit themselves to search algorithms. So there are only two we need to know about, linear and binary. I'm just going to put this on, this comment here. Okay, if you're lost on that topic, it's one topic. Don't worry, don't panic about it. So search algorithms, let's watch a classic video to remind you about how these things work.
What I'm about to do, I'm gonna enjoy it. Fine. I'll do it myself.
So you see that the linear search worked from left to right, just looking one at a time, and it's really quite slow if the thing you want's right at the end.
Avengers, assemble!
A small price to pay for salvation.
Start? I don't feel so good.
So the point with binary search is that with sorted data, we go in the middle. We can see if what we want is on the right or the left, and we can just ignore the half that we don't want. Which is why you remember you guys called it Thanos search.
I am inevitable.
So one of the things with both the searches is you do need to keep track of whether you've actually found it or not, because you do need to return a true or false, like I've got it or I haven't got it. That needs to be sent back. And the big difference is that linear search is ridiculously complex. Worst case scenario, I have to go through every item in the list. Whereas binary search, I halve the number of things to search each time. So it's actually logarithmic. It's reasonably easy to get to a result. Right. Well, with that done, then let's move on to the next slide. Oh dear. Right. Come on, computer. You can do it. Next slide. There we go. Lovely. So I'm going to use a random selection system today to choose which one I'm going to demo working on. So ready yourselves. Which one could it possibly be that I'll have a little look at? Oh, it's linear search. Random generator has told us what we're going to do. So I'm going to jump out now into Replit, and we're going to have a look at a linear search algorithm. I'm going to build one together. Oh, what's this? Oh dear, my last search was on here. An official Breakfast Boys t-shirt. Breakfasting and dinners instead of attending lessons since 2020. What's that on the back? Oh, official dinners breakfast reviewer. Oh, I'm going to have to get myself one of these. It even comes in my size. What a remarkably cheap price. Comedy gold. You thought the scrolling thing was not real. I did spend my afternoon making comedy t-shirts. There we go. So if you want your own Breakfast Boys t-shirt, they are available, as are t-shirts with my classic catchphrase, "It's not in your spec," which I'm going to purchase myself and wear constantly. See, I've got my own merch store now. What did you think was going to happen? How cool. Anyway, right, let's write an algorithm for a linear search. Now, one of the things we need to think about if you were to write an algorithm for a linear search in this paper is it doesn't have to work. It's not going to be in Replit. It's not going to be a real piece of code. It could be in pseudocode. In fact, if you have a look at the mark schemes, in the past papers, mark schemes for both these kinds of searches exist. You can go back and have a look at them, get familiar with them, but they are written in pseudocode. Now, learning pseudocode is quite a difficult task because you can make simple mistakes, as certain people discovered today when they tried to learn the Boolean simplifications and got symbols mixed up. Quick question. Yes, they are real. I did actually put them on a store because I was entertaining myself this afternoon. So with a linear search, what we need to do is start off with something simple like a subroutine. So let's not even bother with that. I don't think we need that. Let's just start off by making a list of items first. So let's call an array my array, and let's put in it an unordered list, because it doesn't have to be in the right order because it's a linear search. So I'm going to do 5. I'm going to do 26. I'm going to do 19. I'm going to do 8, 21. Let's see, and 16. Just a random array of numbers. They can be anything you want. Now, what we need to do then is to ask the user what they're searching for. So I like to use the term needle, as in needle and haystack. And I'm going to do int input. Now remember, int is just the bit that turns it into a number. Search colon. Now this is going to give us the ability for the user to type in what they want and search for it. Now again, in pseudocode there are ways to do this, but I think personally writing this all in Python is much easier. I say that. There are certain members of our class that apparently simply forgot Python for some reason, naming no names. So we've got our search term now, and what we need to do is go through that array. Now in Python this is much easier. So for item in my array, and that goes through everything one at a time. If needle equals item, oh, we need to return the position, don't we? So we need to count. Right, sorry. So let's have a counting variable. I'm going to call it counter, because if I call it the singular of that, me saying it over and over and over again, I'm sure is very close to a word that you find very, very funny. And I don't want to turn into a comedy gold podcast. I don't want that to be memed forever. Anyway, counter can be incremented, can't it? So if the needle is item, I'm going to print out found, and I'm going to print out the counter value. Okay. Otherwise, I don't even need an else, do I? I just need to go counter plus equals 1 at the end of the if. So that's happening within the loop. I also need some way of deciding whether or not I've actually found it. So I'm going to have a found equals false there, and capital F. And what I'm going to do, once I've found it, I'm going to do found equals true, but otherwise I'm not going to bother. Now, outside my loop, if I've got to the end of my loop and I've not found it, then this value here should still be false. So I'm going to say if found equals false, then I'm going to print out not found. It's not too complicated here, is it? It's not particularly problematic. Let's run it and let's see if we can do it. So in that list there, let me search for the number 21. Found it in index 4. 0, 1, 2, 3, 4. That sounds about right to me. Run it and let's see if I can find the number. Let's do the comedy gold number, which of course is 142. It's not found. What a shame. Now, that algorithm is not too complicated, is it? In fact, if it wasn't for me pressing enter all the time, it'd be about 4 or 5 lines less. We've got a basic array and a way of searching. I've got the ability to count where I am, the ability to flag up if I found it or not, and then I've got my loop. I'm going through every item in the array. For each item, I'm saying, is this the same as the thing I'm looking for? If it is, I'll print out the location, and I'll set my variable to true to say I've found it. Otherwise, I'm just going to add 1 and go on to the next one. And then once I'm done, if I haven't found it, if found is false, I'm going to tell them that I haven't found it. And there's a reasonably simple algorithm that would allow you to do that. Just have a look at that beautiful Breakfast Boys t-shirt. Look at that logo. Took me all of 15 minutes to set that up. Look, oh God. Imagine wearing that all around. Imagine me with this on, just shouting the same phrase at you. That is my catchphrase after all. Anyway, right, back to the presentation. Sorry, I do weird things to entertain myself. Yes, I will pop the code on Google Classroom straight away as soon as I've got this done. Don't worry. Right, let's put myself back up in the corner there. And let's get on with the next section. This is the last section. The last section of your questions will be about databases. And it is going to be a reasonably long essay-style question. Now, of course, you can go back and have a look at all the beautiful past papers if you want to. Try and find some information about this. But the databases section is quite repetitive on there. Who gets the money for the T-shirts? Sorry. There it is. Right. Who gets the money for the T-shirts? Nobody. They're set at cost value because I was going to buy one for myself. Don't worry. There's unlikely to be resits. I can't give you feedback, but it's very unlikely to be resits. Don't worry. So databases. Right. There's a few key points to learn about databases. And the main thing is, what are they? Well, first of all, a database is just a way of storing data in a meaningful way. And it takes advantage of all the properties of digital data storage. So it's going to save it in a nice, efficient way that I can get the results quickly. In fact, databases are everywhere and in everything. Facebook is an enormous database. Twitter's a massive database. In fact, Twitch, this very channel from which I'm streaming now, or YouTube if you're watching the lower view numbers, but whichever one you're watching, is a database. It's just storing lots of information and pulling in interesting things that you need at a certain point. And this is what we call a relational database. And this is an example of a relational database here, where we've got a bunch of tables that represent the idea of a student being enrolled in a class in a school. You'll see I've got a table that just has information about the students, one about the classes, one about the subjects, one about the teachers, one about the rooms, and then enrollment, where we join a student to a class. And if you think about that, all of that is quite straightforward, isn't it? It's the idea of storing the different entities, we call them, or the different sort of topics separately. And the reason for that is you wouldn't want to be typing in all the information about a student for every class they do. You wouldn't want to be typing in all the information about the teacher every time they taught a lesson, because you'd be there forever. So we do this and we separate it and we link them. And then we link them through relationships. What we've got here is a one-to-many relationship. In other words, one student can be enrolled in many classes. One subject can be in many classes. In other words, you have multiple computer science classes. And there's another one which isn't represented here, which is a straight line, which is a one-to-one relationship, which means that one of these has one of these. Now, we only tend to use those for like security things, really. They're not really used in database design in the real world. And the way we do that is that every record in the students table, enrollments table, blah, 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 has a key field. And that's a unique identifier, a number that uniquely represents a student, a number that uniquely represents a class, and a number that uniquely represents a teacher. Now, when those key fields exist in other tables, so it's, for instance here, student ID exists in enrollments as well, We call that a foreign key. Excuse me a minute, because my throat is a little bit blocked. That's better. Now you can actually hear me. I don't sound like I'm completely bunged up. So the foreign key is when the key field from one table exists inside another. And the idea there is that's how we link it. We say that subject 4, being, say, computer science, is in here. So there'd be a 4 in this box. So that 4 would point us back to subject 4, which is lovely. I'm just going to put this comment up because this is unsettling, this one. Very unsettling. I'm not happy with that. Right. Let's move on a little bit. And one of the ways we do that is by normalizing the tables. And what normalizing means is we don't want any repetition in the data. We want the data as split and as separate as possible. We call that atomic data. And the reason for that is quite simple, right? If I store first name and surname together as just name, then what happens if I want to send a letter to Miss Morgan or Mr. Jones? Well, I can't, or I probably can, but I've got to process that data again. So I split everything off as much as I can. And I keep each record in a table with like data. That's normalization. That makes the data much easier to search, sort, and keep up to date. And what that does is it avoids me having duplicates of data. I'm not going to have 2 records with your name on it anywhere in the system. I store you once and I use your number to link you to other things. And that means that I don't have inconsistent data. Now imagine, I know a few of you have got interesting surnames or difficult to spell first names. I, unfortunately, was not gifted with that. With a name like David Morgan, I was named in a most boring way, and people don't tend to get the spelling wrong. But a lot of people have names that are a bit more interesting than mine and have a lifetime of people misspelling things. Imagine if every time you had to attend a class, we had to type your name in manually. You would constantly be being chased for being absent, because inconsistent data is where data is entered and is slightly different to others. Now, in our system that we've talked about, we put our name in once and then it's linked with a number, so the name is always consistent. Final thing is easier to change data and its format. So I can change the information if, for instance, you decide that you're tired of your first name because you're tired of everyone spelling it wrong and you're going to join the ranks of Davids. There are dozens of us. And you change your name to something like that where people will always spell it right, then we need to update that in our computer system. And it's easier to do that if I need to update it in one place, not multiple places. And so it can also perform calculations. It can work things out. Why do you think we never ask for your age in a computer system? We always ask for your date of birth. Age will change. Your date of birth doesn't. And the computer can work out how old you are reasonably quickly. It can generate reports, like things to print out, ways of showing data in different ways, and finally, validation and verification. We talked about this fairly recently for the practical assessment, didn't we? And that's easier to do with a database. Now, security is a brilliant thing with a database, because when you've got all these tables, you can just do this. And I'm going to go back and show you that again. This is the entire database. This is what the student, Catherine Stewart, sees or is allowed to see in the database. And I'm going to go back and show you again. Lots of that data has disappeared. The only data that she can see is the data related to her. So it's the classes she's enrolled in, the rooms, the teachers that she's been taught by, and the subject she's studying. But she doesn't have to see anything else. Now that is extremely powerful. Different views means that I can store the data in one place and only show people the data that's relevant to them. So security is really, really easy because I'm only showing the data that's relevant to the right people. I can also put a password on it and lock the entire thing behind a username and password, which of course is absolutely simple and straightforward in computer science, but that's more difficult to do if I have, say, I don't know, just a spreadsheet with all of this in. I can also give myself read-write access to different tables. So in this picture now, the only thing I'm allowed to change is that enrolled table. I'm allowed to enroll people in classes or unenroll them. What I'm not allowed to do is go in and change the name of the teacher to something comical or cancel a computer science class. But I can add people to the class and remove people from them. And that might be a real use case, you know. The person in the admin department who's responsible for signing people up for classes, should only be able to add a person to a class and shouldn't really be poking through the other data. So giving read and write access to different parts of the table is certainly very, very easy in a database and very, very, very powerful. And that's it from me. That's all of the topics covered for tonight in amazingly quick time. I'll just very quickly wait for a few minutes for the video to catch up with me. And if you've got any questions about the assessment tomorrow, of course, please pop it in there. Do excuse me, my nose is running quite a lot. I'm just going to pop this up. Speed running the stream, right? Just let me point this out, right? I know some of you speed ran the assessment today, but let me just put it this way. It was quite evident in some of your marks. They weren't quite as high as they could have been because when you speed run things, you do make some mistakes. So maybe don't speed run the one tomorrow. If you can do that for me, that would be lovely. But it's not massively problematic. Don't panic too much. Well, we do have them. I did actually put them online because I wanted to buy some. If you want them, I can pop the link somewhere for you. Let's have a look. I'll pop it in the chat. Obviously, I think that's it. Go. Don't go and buy anything from there. I'm going to get them for myself. But if you want to have a nose, they are a real thing. It has amused me. Thank you for that. And apparently, some people took their time. So yes, there are undoubtedly ways to get better marks in the assessment tomorrow. It's not quite as mathsy and just working things out. It is more just remembering things and reiterating it. But one of the key things that you have to do is ensure that you are answering in full sentence bullet points. Please do not be tempted, because it's an essay question, to write it like a history essay and do paragraphs. You're better off structuring it with single sentence bullet points because you won't repeat yourself. And one of the key differentiators in the mark scheme between a high achieving answer and a low achieving answer is whether you've repeated yourself or not. So use the bullet point setup so you don't repeat yourself. I think it depends. It really depends who was doing the taking, I'd say, with that one. And yes, but again, don't waste your money on this rubbish. I've just knocked it up because it was amusing to me to, at the end of a live stream, go, oh, I've got a merch store, aren't I comedy gold? And then reveal it was actually a real thing. So yeah, please don't waste your time on this rubbish. There's more impressive things that you can buy for yourself. But I'm going to leave you now, guys. Make sure you do a little bit of revision. When have we got the assessment tomorrow? Is it first thing? Let's have a quick look. It is first thing tomorrow. So after first lesson tomorrow, we will be done. We'll be dusted. We'll be finished with the assessments. Woohoo! And we can then start focusing again on the Year 13 project, which is a bit more fun than revising for a bunch of assessments all the time. Right, guys. Have a good night. Do a bit of revision. Make sure you get to bed and have a good rest. And I shall see you tomorrow. And again, don't waste your money on this rubbish, please. It's really not worth it. See you tomorrow.